Hello, students. Welcome to today's lesson on scientific notation. This is the first of 2 lessons on this subject. Learning about scientific notation is very important because you will use it in your other studies, such as chemistry, biology, and physics. Are you ready to begin the lesson, students? Let's get started. Scientific notation is also known as standard form or as exponential notation. It is a way of writing numbers that accommodates values too large or too small to be conveniently written in standard decimal notation. Scientific notation has a number of useful properties. Students, what kind of people do you think use scientific notation?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. An obvious answer to this question. Scientists, do you know what the number 300 million meters per second represents? It is the speed of light. What about 0.00000000753 kilograms? That is the mass of a dust particle. you can probably understand why scientists need a different way to show very large and very small numbers. I would not want to have to read that number very often. Other people that use scientific notation are doctors, engineers, geographers, biologists, and, of course, mathematicians. Most calculators and computers also use scientific notation when there are too many numbers to display on the screen. Scientific notation gives us a shorter method to express these numbers based on powers of the base number 10. Let us try an activity. Students, by what powers of 10 must you multiply 2.5 to get 25? What about 250? Or 2,500? Please write your answers now.
Students, let's get ready. Let's get back to our lesson.
Welcome back, students. I am sure that you found this activity to be quite easy. To turn 2.5 into 25, we must multiply it by 10, which can also be written as 10 to the power of 1. To get 250, we multiply it by 100, which is 10 to the power of 2. To get 2,500, we multiply it by 1,000, which is 10 to the power of 3. Great work, students. We can express this method mathematically by saying that if n is a positive integer, multiplying a number by 10 to the nth power moves its decimal point n places to the right. Students, what do you think will happen if n is a negative integer? Please think about this and then write these numbers in standard decimal form.
Students, let's get ready. Time's up. Let's get back to our lesson.
Hello again, students. I am sure that if you thought this through, you came up with the correct answers. When n is a negative integer, the decimal place moves in the opposite direction, to the left. Therefore, 2.5 times 10 to the power of negative 1 is equal to 0.25. 2.5 times 10 to the power of negative 2 is 0.025. And 2 0.5 times 10 to the power of negative 4 is 0.00025. Using this method, we could have expressed the mass of a dust particle as 7.53 times 10 to the power of negative 10 kilograms. That is much easier to say. A number is said to be in scientific notation or standard form if it is written as a product of the form A times 10 to the power of n, where A is greater than or equal to 1 and less than 10. In this form, A is called the coefficient, and 10 is called the base. N is referred to as the exponent or power of 10. In scientific notation, 2,890,000,000 becomes 2.89 times 10 to the power of 9. How? Remember, students, that any whole number can be written with a decimal point. Next, we move the decimal place until we have a number between 1 and 10. If we keep moving the decimal point to the left in 2,890,000,000, we will get 2.89. Now, we count how many places we moved the decimal point. We had to move it 9 places. We show this movement by noting that the number should be multiplied by 10 to the power of 9. Students, do you recall the measurement of the speed of light? Please note this down. The speed of light is 300 million meters per second. Write this number using scientific notation.
Students, let's get ready. Begin. let's get back to our lesson.
Hello, everyone. In scientific notation, the speed of light is written as 3 times 10 to the power of 8. A power of 10 with a positive exponent, such as 10 to the power of 5, means the decimal was moved to the left. A power of 10 with a negative exponent, such as 10 to the power of negative 5, means the decimal was moved to the right. Today, we have learned about scientific notation. We have discussed why and in which fields it is commonly used. We have learned how to express very large and very small numbers by using positive and negative integers. Until next time, thank you, teacher. Thank you, students.